In this video, we're going to solve quadratics using the quadratic formula. We will not derive the formula. We will just focus on how to use the formula in order to arrive at our solutions. So, first thing we have to be able to identify in our equations is going to be what these letters stand for, the A, the B, and the C. How do we identify those letters in our equation? So, in general, we write quadratic equations like this, where the A, the B, and the C represent the numbers in front of, well, the A and the B are the coefficients for the x squared term and the x term, and then the C would be just the constant that's added to our quadratic. Okay, so in this case, looking at our first example, we have A is equal to 1, because that's in front of the n squared, and B here would also equal 1, because it's in front of the n, and then C would equal negative 56. Now, in this case, I would not choose to go to the quadratic formula because of this. I see that it is actually possible to factor. So I can write n and n, and I can write this as positive 8, negative 7. Because I know 8 times 8, or I'm sorry, 8 times a negative 7 will give me negative 56. And I also know that 8 plus a negative 7 would give me positive 1, which is my middle term. So if it's easily factorable, we can jump right to the solutions. N equals negative 8, n equals 7, and we're done. We don't have to actually go through all the computations of the quadratic formula. But not all quadratics are factorable. In fact, when I look at the one on the right, well, first thing is, I can't solve any of these quadratics unless they're equal to 0. So I have to make sure that I add 5 to both sides of my equation to get 6a squared plus a, subtract 100 now, equals 0. This doesn't seem like it's very easily factorable, especially when I look at the leading coefficient here, will be the 6. It's not 1. When it's 1, in most of the cases, you can tell kind of right away whether it's going to be factorable. In this case, if I have to think too long about factoring, I'm going to jump right to the quadratic formula if I can't figure it out. Now, this may be factorable. However, if I can't figure it out right away, I'm just going to fall back on the quadratic formula because it works for solving any quadratic equation as long as it's equal to 0. So in this case, A would equal 6, B would equal 1, C would equal negative 100. So I'm going to go ahead and plug this into my formula. Opposite of B, plus or minus b squared, which is 1 squared, minus 4 times a, which is 6, and c, which is negative 100, all over 2 times a, which is 6. So I'm going to do the calculation for this big number underneath my square root, and that would give me the square root of 2,401 all over 12. And if I do the square root of 2,401, it is 49. So it can be x equals plus or minus 49 all over 12. So now this takes us in two directions. 1 will be x equals minus 1 plus 49 over 12, and the other one would be x equals negative 1 subtract 49, all divided by 12. So doing these calculations, we get 4 and this would be minus 50 over 12, which is not a nice number, but we can reduce this to negative 25 over 6. Okay, and there are two answers, and you see that when you get a rational number, negative 25 over 6, a non-integer number, that probably means also, in hindsight, that solution wouldn't transfer very well to factored form. If you look back at the first example, my solutions are integers. Those integers are easily identifiable in the factored form. Okay? So there's our tutorial on how to solve quadratic equations using the quadratic formula.